Good morning. Good morning. We'll start in 1 more minute. Just give people time to settle down. Good morning. Let's get started. Welcome to the session on what's new in Couchbase Server 4.0. My name is Chin. I'm from the product management team at Couchbase. Many of the engineers and architects who work on 4.0 are here today at the conference, so it's my honor to represent their work to you. My goal today is to give a quick tour of 4.0 key features to get you excited about 4.0 so that you download the beta and start building new applications and share your feedback with us. I'm going to cover, in the 30 minutes that I have, broadly 5 key areas in Couchbase Server 4.0. I'm going to talk about Nickel that we mentioned in the keynote. And I'm going to talk about indexing that make your application and queries run faster. And many of you come to know SQL for the ease of scaling. And we're taking it to another dimension in 4.0. I'll talk about multidimensional scaling. In the storage engine area, there are a lot of cool names. You have heard about ForestDB, Tiger, and we have our very own ForestDB. I'll explain what that is. And I'll close by highlighting a couple of features that we have in security in 4.0. 4.0 is our biggest release so far. Represents hundreds of man-years of effort over the last 2 years. And I'd like to take a couple of minutes highlighting some of the other important features in 4.0, just give you a sense of the scope of the release. Assume that you're familiar with SDCR, cross-data center replication functionality. In 4.0, we have a filtering capability that allows you to specify the criteria and only replicate a subset of a data. So this is very useful when you have data centers all over the world, and you don't necessarily want to replicate all the data to all the data centers. So you have a lot more control over what you replicate to which data center. Bloom filters is a very compact data structure that we implemented in 4.0 to greatly improve the performance of a DGM use case where you can only cache a small number of objects in your memory. And it basically is a data structure that allows the system with high probability to detect whether an object is in the database or not without having to do unnecessary IOs. We also improve our memory management, cluster robustness, and introduce a breakpad library that generates a more compact and readable crash log, so therefore easier debugging. All SDKs have been enhanced to support 4.0, including Nickel. And there are many sessions in the conference today in the developer track that talk about various SDK support if you're interested. And we also created and improved the platform support in 4.0. We added SUSE support and Oracle Enterprise Linux based on popular demand from our customers, and it'll be in 4.0. So let's get back to the 5 core features. Let's start with Nickel. So Ravi mentioned that Nickel is basically we're bringing the power of SQL and combining it with the flexibility of JSON. So as a developer, you have the benefits of dynamic schema and the modern capability of JSON document database, but then and combine that with the proven and establish a query language like SQL, which is a standard to support the JSON data model. When you're evaluating a query language, there are 3 key requirements that you should consider. The first one is how expressive the language is, meaning can you express what you need to get done without having to write a lot of custom code to work around the limitation of the query language. Is it declarative? Declarative means that can you specify what you need to accomplish without having to worry about the complexity of how to do it efficiently in your application code. And then you need to consider the ecosystem. That includes the ecosystem of end users who understand SQL, developers, and the application and tools built around the language. How many of you are familiar with SQL? Let me give a show of hands. Quite a number of you. So let me talk about each one of the criteria in more details. Let's start with expressiveness of the language. Ravi showed the travel app example at the keynote. I'm going to use a couple of e-commerce examples to further enhance the point. Let's say you're running an e-commerce site, and you want to find out what the top selling products are. So without having the right application, you can do that with a simple SQL statement. Basically, what you do is that you go through all your purchase orders. Within the purchase order, you pull out all the line items from the purchase order using the unless operator. You join the line items to the product it's referencing to find the product information. You do a group by, so you group all the line items by products. You sum up the units sold, you order by it, and then you limit to the top 10. So a fine-line SQL statement gets you the top 10 selling products. Here's another example. So your boss comes around and asks you about the monthly sales. So again, same data model. And what you do now, instead of grouping by the product, you're grouping by the purchase date of the line item. Shown here using substring to put out the year and month sold, and then you can do a simple order by month and sum up all the items and show it in millions. So there you go. You can quickly, in 5 minutes, you can generate a report of monthly sales for your boss. So for those who know SQL, very quick to get the report you need, and your boss will think that you're a genius. Let me give you another example that people typically don't associate with SQL. And just to show you the expressiveness of SQL and the range of application that can build using SQL. This is an example from a partner, Multidimensional. It's a startup co-founded by 2 veterans from Facebook and Google who work on their big data project. And they have a sample that shows how to generate a mosaic picture from, for example, you go to a vacation, you're taking your favorite picture, and you want to generate a mosaic picture from it. And basically, if you zoom in, this picture here makes up of a series of small gallery picture. And you can generate this by using a simple SQL statement. Basically, what it does is it loops through all the pixels in the original picture. For each of the pixels, find a matching gallery image in terms of the RGB color. And there you go, a simple SQL statement operating on potentially millions of pixels, finding you the right gallery image so you can stitch together in the application to create the mosaic picture. So that's power of a query language like SQL. It's built on top of relational calculus and algebra. It's very expressive. It's been proven over the last 3-4 decades in the database of de facto query language used by the industry. So what we've done in 4.0 is extend the language to support the JSON data model, so you have the best of both worlds. To learn more about Nickel, we have an online tutorial that steps you through each of the Nickel functionality, so you can interactively learn about Nickel if you're not familiar with it. Basically, it's at query.couchbase.com/tutorial. There are many sessions in the conference covering Nickel. Ravi mentioned the one introducing Nickel by the lead architect, Gerald. And this is the only session that we repeat twice at the conference. That's how important it is. So we have one this afternoon and one repeated again tomorrow so that you don't miss it if you have a conflict. And the session on the SDK support for Nickel in various languages this afternoon at 4:30. And for those who are thinking of migrating for RDBMS to Nickel, this is a session that shows you how to do the migration. And you find it's a lot easier than other NoSQL technology, mainly because Nickel is a superset of SQL. So it makes the migration very seamless. A big data query landscape is a survey and comparison of the various query languages in the industry using a framework developed in a university by Professor Yanis called SQL++. I encourage you to attend the session. And there are 2 sessions by our customers, early customers using Nickel, one by Nielsen and one you heard this morning by DirecTV. So a lot of interesting sessions on Nickel. Let's get back to the second requirement, language being declarative. What do I mean? By being declarative means that the language allows you to specify what you need to accomplish, and you let the system does the heavy lifting in terms of optimizing the query and understanding what the best way to execute to get the result that you need. And this is a high-level architectural diagram of a query engine. Basically, we take a SQL statement, we break it down into the algebraic operators, and then we process the data through it. In many cases, we parallelize the processing. And let me use the top 10 example to illustrate how powerful that declarative language is. So in this 5-line SQL, you're looping over potentially tens of thousands of purchase orders. You're doing, for each purchase order, you're doing the unpacking. And you're joining into the product get information. You are doing group by and sorting, and then you're picking the top 10 products. So there are a lot of processing that's going on, potentially over tens of thousands or millions of objects. And you want to do that in the data tier. You want to do it close to the data and do it efficiently, and leveraging a complex engine to understand how to optimize it, leveraging the various indexes, and understand where the data are laid out, and parallelize the operation and get the result to you very quickly without you having to worry about it. That's the power of declarative language. And if you want to learn more about the details, how a query engine is, there's a session by Chihan that talks about 4.0 architecture in general right after this. And then there's a deep dive into Nickel where it takes the picture I show you to talk to each of the operation and show you what happened when we take a query statement and then we pass it through the query engine and what kind of processing we do at each step. So it's a good session if you want to understand the internals of a query engine. And then was another session on the optimization for performance. And if you're an architect that you're thinking about how to leverage NoSQL and Nickel to meet some of the challenges you have, this session tomorrow is a good one to go to. Ravi also mentioned ecosystem. So because Nickel is built on top of SQL, which is a standard for the last 3-4 decades, and with the ODBC, standard ODBC and JDBC driver, it opens up a whole range of ecosystem that's available today. So at the conference, we have announced various partnerships with the vendors up here. And we have many sessions by our vendors. So Local is a BI vendor. You have Informatica ETL vendor. And Tableau and Metanautics are, again, the BI vendors. And then you have Simba, who built ODBC, JDBC drivers. So again, if you're interested in the tool ecosystem of Nickel, I encourage you to go to these sessions. So let's talk about indexing. So indexing, basically, as I mentioned earlier, indexes are used to quickly look at objects, meaning criteria that you specify in the database without having to scan to every single object. So basically, it's a quick way to look up, to search for needles in the haystack, in a sense. And in 4.0, we support various sub-indexes, primary indexes, secondary indexes, spatial, and text. I'll explain what they are quickly. Many of you are familiar with the primary. Let me use a library example as an analogy. So in a library, most books are organized by the ISBN number. So basically, the ISBN number is the primary key. And using ISBN number can locate the book on the shelf very quickly. What if you want to look up the book by author? In that case, you can either go to the books one at a time to look for it, or you can go to, as Ravi mentioned, a library catalog that allows you to look up the books by the author and then map it to ISBN number, and from that you can look up the book efficiently. This is what we call the secondary index. The secondary index basically allows you to do efficient lookup based on attributes of an object other than the primary key. If you want to look for books written by authors that live within a certain area, in that case, you want to do what we call spatial query using some coordinates. And if you look for books on Couchbase Server 4.0, basically you're doing a search, you're using a search engine that relying on a text index that look up information based on the content of the books. So these are the various type of indexes that we support in Couchbase 4.0. I won't go over primary indexes because most of you are familiar with the primary index provided by Couchbase. Basically allows you to read from a document key, map it to the bucket, to the server that contains it, and quickly retrieve the object in sub-millisecond. Let me spend some time on secondary indexes. So we do support what we call local secondary indexes in 3.0. Basically what that is that the index are co-located with each of the data nodes. So this is supported as map-reduced views in 3.0. So you have pretty good write performance because the index is co-located with the data that you're writing. So as you're writing to the data, you can update the index within the same node quickly. Read typically suffers because we have to do what we call scatter-gather. So to do a query like finding objects that meeting certain criteria, you have to go to all the nodes, issue the query, look up the index. That's what we call scatter. And then gather the results from all the nodes, combine it, and return back to the user. So under heavy load, if you have a lot of indexes and if you have a lot of data nodes, you may hit some a bottleneck with our current technology. That's why we introduced what we call global secondary indexes. They are separate from the data nodes, and they lead to much higher performance. You can scale it and partition it independently, and they can isolate the operation from the key value operation, so you minimize the interference. And I'll talk about it more in the section of multidimensional scaling. So this is probably one of the key release-defining features that we have in 4.0. So I'm grossing over it very quickly, given the time that we have. There are 2 sessions on our secondary indexing in 4.0. One, again, by our lead PM on the Couchbase server, Chihan, that give you a broad introduction over the capabilities. And then there's another session this afternoon, a deep dive into the secondary indexes. This is probably the most technical talk at the conference, at this conference. So for those of you who want to understand how the system design architecture of secondary indexes, how we optimize it for high performance and throughput, how you partition it for availability, and how the system leverage multiple indexes for parallel queries and for availability. This is a session to go to. Your head may hurt a little bit after the session, but it's a good one to go to. Spatial indexes. So we supported spatial indexes as experimental mode in 3.0 and officially supported in 4.0. So many of you are familiar with spatial index. Basically, especially we can do bounding box and range queries on the index, like finding all the points within a certain region or finding all the objects that overlap within a certain region. Spatial indexes are basically what we call R3. So they're actually multi-dimensional indexes. So many of you may not know that actually can use spatial index to do multi-dimensional queries on any numbers. For example, you can, let's say you have a population in San Francisco, and you can use spatial index to analyze the population by age, by income level, and by educational level. So you're doing basically 3-dimensional analysis on the population. So again, spatial index not necessarily restrict you to only geo-related queries. You can do it on multi-dimensional queries to do multi-dimensional query. Or I can combine geo queries with other dimensions. For example, you can find everyone who lives in San Francisco that's between 18 and 24 years old. And there are a lot of them in San Francisco. It's a popular place for kids nowadays. So that's spatial queries. And we have a session on spatial index and how to build spatial web application tomorrow at 4:30 by our solution architect, David. So I encourage you to take a look at that. Text indexes. So we're announcing today that the developer preview of our full text search capability. we have supported integration with external text search engine, such as Elastic, Solr, and LucidWorks in 3.0. Louder. Thank you. Yes. And we heard from many customers that for simpler use cases, you want an integrated solution that's easier to manage. It may not provide all the functionality. It may provide 80% of the functionality, but it runs within the same cluster. You use the same tool to manage it. It's a fully integrated solution, and that's what we provide in 4.8 as a developer preview. And I encourage you, if you're interested in text indexes and full text search, go to the session by our co-founder, Steve, and the lead architect, Marty. There's a session later today at 5:15 on a full text search capability. So now we have data service, we have query service, index service. Multidimensional scaling allows you to independently manage and scale these various services. Let me spend a few minutes on it. So many of you are familiar with the horizontal scaling. The ability, so basically you are running homogeneous set of nodes. All the nodes are running the same services. And if you need more capacity to deal with some peak load, you just add more servers. So it's very straightforward, very simple. And this is what we provide in Couchbase Server 3.0. With multidimensional scaling, you have the option to separate out the services as shown in the keynote demo and run them on different nodes. So this minimizes the interference of a service on another, like say on the data service. In some deployments, it's very important that the complex queries load that you have doesn't impact the critical transactional key value data operation that you're relying on. So in that case, you want to separate them on different servers, and you want to manage and scale them separately. The other benefits of multidimensional scaling is that it allows you to tune the hardware configuration for based on the requirement of the service. A data service is pretty simple. You can run it on commodity hardware. All you need is more memory and storage for each data node, and you can scale it horizontally quite easily. For index, you may need, because there's heavy traversal of the index tree, you may need more storage. You may need a box with faster storage. And for query, since you're running a lot of complex processing, you may need a bigger box that has a lot of CPUs and memory so that can run many complex queries on these boxes. So again, it allows you to, based on your requirements, scale the service either horizontally or vertically based on your needs. We have one session on multidimensional scaling and a demo of it in more details tomorrow at 10:30. I encourage you to go to that session. ForestDB. So this is, Ravi mentioned that we architected Couchbase Server to leverage fast memory and fast network. So that's our core. That's how we can scale and run really fast with the integrated cache and with memory-to-memory replication and syncing technology we call DCP. But fast storage is another key component of our system, because eventually you have to write and read data from the disk. And let me give you a quick overview of the two popular storage engines in the marketplace today, so you can have a sense of the comparison. The first one is what we call a B+ tree. So it's B+ stands for balanced tree. Basically, all the leaf nodes is of the same distance from the root. And B+ tree tends to have pretty good read performance. If you have a lot of keys in a given node, what we call the fan out is high. So basically, you have a short and bushy trees. And to get from the root to the leaf node, you only have to traverse a few hops. However, performance degrades if your key get longer. Your fan out decreases, your tree get taller, and to get from the root to the data node, you have to go through a lot of intermediate index nodes. And if you're doing update in place for updates or writes, B trees tend to suffer as well, because the index nodes and the data nodes tend to be scattered randomly on the disk. So we're doing a lot of random IOs to do the updates. So this is used by many popular products, including MySQL for InnoDB, And Couchbase 3.0, Couch Store is based on this technology. And same for MongoDB, the new WireTiger B+ storage engine is based on this storage structure as well. The other popular storage engine storage structure is called LSM, LSM3. LSM stands for Log Structure Merge 3. So basically, LSM3 is optimized for write performance because by leveraging in-memory index data structure to defer the write to the index, so it can batch all the writes to the index, and by using a sequential log to write up the data nodes. So you're writing things in sequentially, and you're deferring the writes to the index, and then you flush it up periodically. So it tends to have pretty good write performance, but not as good in terms of read performance relative to B+3 because potentially you may have multiple trees that you have to traverse to get to the data that you need. So you have two common storage data structure in the industry. B+3 optimizes for read, and then you have LSM3 that's optimized for write. That's why MongoDB actually provides two separate engines, WireTiger B+ and WireTiger LSM, and as a developer, you have to pick and choose. So we step back, and a few years ago, we fundamentally rethink the requirement of a storage engine for modern application, web-based, mobile-based, and managing IoT application. And we want a very compact, efficient storage engine to deal with a variety of data from these applications. And we want a single engine that scales well across the different workloads. So because we believe that most of the customers that we have, they're running a mixed workloads of reads and writes. So we want an engine that works well in a mixed workload environment. And we want to design an engine that actually scales from a small device on the mobile for Couchbase Lite all the way to a big server in the cloud for Couchbase Server. And we call our engine ForestDB. And so based on, I don't have time to go into the details of ForestDB. Based on internet benchmark, the structure that we came out is 5 times more compact when we compare to LevelDB from Google and RocksDB from Facebook. It's up to 6 times faster in a variety of workloads. And it's designed to take advantage of SSD technology. So the details behind this, Ravi mentioned, this is basically hierarchical B+ tri-tree. And we first introduced it in ACM SIGMOD back in 2011 as part of the contest. For those of you who are not familiar with SIGMOD, basically a special interest group for database practitioners and researchers. And basically, tri-tree stands for prefix tree. It's a technique for compressing the key. And we introduced what we call the chunking technology to chunk each key into fixed size, again, to minimize the storage per node. And each node on the tri-tree is itself B+3. So basically, we have a collection of B+3, and we call it ForestDB. And to go into a lot of details, you should go to the session by the lead architect of ForestDB, or storage engine, Chi-Young, today at 4:30. So you get into the details of our storage engine, the structures. You walk you through an example of how why it's a lot more efficient and more compact, and share with you some benchmark data. We're also doing a joint presentation with Professor Lee from a premier research university in Korea on how we're optimizing ForestDB for SSD, and we're actually influencing major SSD vendors on the API that they should expose so that a NoSQL database like Couchbase Server can run a lot faster on SSD devices. And then we'll have a joint presentation with Intel, sharing some of the benchmark data that we jointly did with them in the Intel High Performance Cluster Lab. So if you're interested in benchmark data, that's a session to go to. So I covered nickel, I talk about indexing, I cover multidimensional scaling, and we talk about our next generation storage engine. Let me conclude by highlighting a couple of features in security in 4.0. So we have been, as Ravi mentioned in the keynote, we have been adding security feature in every release of Couchbase Server. So we added things like password protection management, admin roles, secure communication, encryption for data in motion and data at rest, And in 4.0, we added 2 key features in security. The first one is LDAP integration. So with 4.0, you can manage all your user identity centrally using LDAP. And then we'll allow you to map the LDAP user into the admin roles within Couchbase. So now you can audit the operation by individual LDAP users within Couchbase for security compliance reason. And we're auditing more than 25 admin operations. And the records are simple JSON objects, so it allows very easy downstream integration with popular log management and visualization tools such as Splunk. And this is a sample of what the audit record looks like. So basically JSON, a simple JSON structure that shows you who does what, when, and how. So, and you can pipe it to your favorite log management tool and visualization tool to visualize, to analyze all these events. So there are 2 sessions on security, one by Don Pinto, the lead PM on security, so give you a broad coverage on all the security features in up to 4.0. And then we're doing a joint presentation with a partner, Vometric, on encryption. So if you're interested in how you encrypt your data, both in motion and on disk, this is a good session to go to. So in the last 20 minutes, I give you a quick tour of query language NICL. I'll talk about the different index types that we have. I'll talk about how you scale the data, query, and index service independently, and how you can isolate them. Give you a quick overview of ForestDB relative to B+3 and LSM, and then highlighted two key security features in 4.0. I hope that gives a good sense of what's coming in 4.0. 4.0 actually available for beta today, and I encourage you to download it at couchbase.com/beta, and so you can download the beta software. It comes with the travel sample app as well, so there's a sample app that you can walk through and see how it's built using SDK, and how you can use what kind of NICL statement that we're using within the application to build that travel app. And we encourage you to try it out, build new applications, and share your feedback with us. Thank you. And now we can open for Q&A. Yes. So the question is, what is the GA date for Couchbase Server 4.0? So we are in the phase of, for all of you are familiar with building complex software, we're in the phase of doing performance testing and doing final system integration. So the beta 1 is available, and we're targeting end of Q3 and early Q4 for GA. That's what we're targeting. And a couple of customers are already using early version of 4.0 to build the application, as you have heard from DirecTV and Roomlier. So if you're interested, we're going to have a broad beta program where everyone can participate and submit questions on forum. But we also have a selective beta program for key customers who have a strong use case and who's going to partner with us and go production when we GA and be a reference for us. And if you're interested, let me know. And you have access to product management and you have direct access to engineering if you're part of that program. Yes? What is the upgrade path? So as in most of releases, it's backward compatible. So the query service, the index service are new services that we introduce. If you're using a basic key value stores with views today, you can upgrade that seamlessly. So it's the same data format. We haven't changed that. Yes? Can you say that again? Yes. So how do you migrate data from other data sources, either to and from Couchbase? So we have various connectors that were built, And including integration with a tool like Talent or Informatica that allows you to extract, transform, and load data from into Couchbase. And with various connectors to the Hadoop ecosystem as well. So we're connected to Hadoop, and we're connected to Spark and various key ecosystem. And many of customers in real time, they're doing Kafka integration as well. So if you're generating data in real time, you can pipe that into, stream that into Couchbase. Yes? OLEDB and 8, so we support JDBC and ODBC. How about OLEDB and ADO.NET? So I actually do not know the answer to that. Chihan, who's the lead PM here.
Hi, I can answer that. I'll stand close to you so they can. Okay. So OLEDB is not a standard that Microsoft is continuing to support. I don't believe that there's any updates to OLEDB anymore. So we don't have support for that. ADO.NET, you can come through ODBC. So if you go to system.data.odbc, you'll be able to come through ADO.NET, through an ODBC driver that can actually seamlessly work. But there's some interesting other components that we're looking at. Link is one of them. So if you want to come through Link, if you're a .NET developer, that will be available. And I believe there are previews of that available as well that you can take a look at if you're on GitHub. That's a good question. So I'll repeat it. How do you actually decide to go from a topology that is more like maybe horizontal homogeneous scale out to an isolated MDS kind of topology that essentially isolates indexing and query? And how do you actually size these things? So it's a question we're still measuring. There is a lot of interesting characteristics and a lot of different workloads that we get. Some of them are extremely read-intensive, some of them are extremely write-intensive. And depending on what you're sensitive to in terms of latencies and which part of your workload you actually like to tune, either could be an option. But I think one of the things I can tell you is we'll continue to publish more and more data around this to give a lot more guidance. What we also expect for a lot of people is that they will actually start with just homogeneous horizontal scale out with all of these services, and then they will eventually move to using MDS as their systems grow and as they gain more comfort with that model. So these are two elastic models, and you can change them. How you scale and size this is quite a complicated algorithm sometimes based on the architecture. So the answer varies very much on what you really like to optimize. Yes?
Question on sizing the cluster now. Because when we do the sizing exercise, so far it was just on a set key metrics that would pick up, and we had the algorithm to say that, okay, outcomes this number should have a 5-node cluster or a 6-node cluster. Now, you've got to take into account how the queries are coming in, what kind of dependencies are. So all of this is front-loaded. What is the impact of all of this on the sizing?
So,
how are we going to go around doing sizing?
Yeah. I think my brief answer is the trio sizing that you've done for the KV continues to be valid. And the added components that are coming in, they have, if you actually do horizontal homogeneous deployments where every service runs on every node, then you'll find yourself having competing services that are going to require more memory and more processing capacity. The formula isn't that easy for me to just spell out right now, but it's something that we're measuring to give you guidance by the time we release the product. But yes, there is when you add nickel on top, you do have to reserve capacity, computational capacity for nickel and indexing as well, as you use more of these capabilities. The one thing I'll mention, though, is you don't have to turn these things on. So you can actually run a trio-like environment as well, and that's sized very much the same way. I think time is up.
There's one question in the back. Can you speak out, please?
I'm sorry, I didn't get to hear that. Did you guys?
So Don, can you repeat that question?
Yeah.
Yeah, so repeat the question.
Yeah. So the question is, can you change a node's set of services dynamically without downtime? The answer is yes. You can go from the model of homogeneous kind of set of services on every node to a completely isolated service without any downtime. Yep. Excellent. And
Thank you. So I'll be around. If you see me throughout the conference, stop me. I'd love to talk to you. And again, we have a beta program for key customers. So if you're interested, talk to me, and we'd love to work with you. Thank you.
But I don't need that one. I do need this one. Can I plug this in? What's that? There's no audio. I should turn this off. Do we get started right away?